We have observed a new boson with a mass of 125.3 plus or minus 0.6 GeV at 4.9 standard deviations. Thank you.
At the level of 15% compared to the old analysis.
I'm Dr. Sinead Ryan from the School of Maths in Trinity College.
We're here today at the Science Gallery because the Large Hadron Collider has finally smashed those two particles together, and they have come up with some results, the first results. They're looking for this Higgs boson. They haven't quite found it. Can you explain what today's results show?
Sure. Today's results are fascinating, very interesting results. What they have announced is a significance of 4.9 sigma, as we say in the particle physics community, which means almost a discovery. A new particle has been observed at a mass consistent with that expected for the Higgs boson, and also with showing properties that are consistent with what is expected for the Higgs boson. However, these properties have not been tested, and some of the properties of the particle itself remain unknown as yet, which is why it's not been formally called the Higgs boson.
What is a boson and who was Higgs? Why are we looking for this God particle that's been nicknamed?
Well, the Higgs boson was postulated in 1964 by Peter Higgs, amongst others. There were 6 theorists working in 3 different groups who actually came up with slightly different theories, all with the same basic idea, to explain how fundamental particles in our universe, such as quarks, gain mass. And they gain their mass through interaction with what's called the Higgs field, and the Higgs boson is the particle associated with that Higgs field. So really, if we understand our theories of the Standard Model correctly, then we need this Higgs boson is the missing particle in that theory, which verifies our understanding in some sense of particle physics to date. What's interesting will be what comes next, whether we in fact understand this Higgs boson, whether it is just a Standard Model Higgs boson, or whether in fact there is more to tell about physics beyond the Standard Model.
So for 50 years they've been looking for this tiny piece of, which is probably inconceivable to the mind, how tiny this part of mass is, but it's the reason everything exists. It's the reason you and I are made of bones and skin, and why we have concrete, and why we have all the building blocks of our universe. We're missing this teeny tiny part, and today they've come really close to saying that they found this final piece.
Yes, that's right. The Higgs field and the Higgs boson were created in the billionths of a second after the Big Bang, and these are the conditions that are recreated at the LHC to allow us to probe and to try to understand really where we came from and what the fundamental questions, answer the fundamental questions about what the universe is made of, and do we understand the physical laws of our universe. It's a remarkable achievement.
And that's obviously where the nickname, the God particle, comes from, is why are we here today, and how does our universe keep evolving and changing. So it's really fascinating for someone who's not even a scientist. It's just really interesting. You mentioned there the Large Hadron Collider. What is this, and what is the significance of that huge machinery that we saw the pictures of today?
The Large Hadron Collider is the single largest scientific instrument on the planet at the moment. It's been designed and built to, as I said earlier, recreate the conditions billionths of a second just after the Big Bang. It's a huge international undertaking with member states from all of Europe, except for Ireland, unfortunately, and also associated states, the US, for example, and others. It's a massive international effort with thousands of scientists working together. It's a large 27-kilometre ring underground at the Swiss-French border near Geneva, where protons are collided millions, billions of times per second, to understand and observe what comes out of these collisions, to understand what happened at the early universe.
At CERN today, where we were watching the scientists, and that was streamed all over the world, and I was watching the room, there was about 30 people in there, and staring so intently at the screen, I couldn't understand any of the graphs, X, Y axes, I hadn't a clue, but this seems to be, like you said, an international effort among scientists, and there was people here today with their laptops on their backs, people who were probably on their way to work, who called into the Science Gallery to see what this was all about. This is a huge step in, I suppose, the scientific discovery of what's the future of how we understand our world.
Yes, I think so. I mean, I think it's fascinating for scientists and non-scientists alike, and if you are interested in the world around you, if you have some curiosity about nature and how how things work, then this is a huge day. And in general, particle physics provides that level of excitement, and it's driven by curiosity about how the universe works and where we came from ultimately. It's a great thing to be part of.
Well, finally, at CERN this morning, the speaker was telling us that up until last night they were still gathering data and including the information that they had on their slideshow for this morning. Where do they go from here? Why today's announcement, and is that just the marker to start off more of their discoveries and more of their experiments?
That's right. The Higgs Boson has been the holy grail in some sense. It's the marker for completing our understanding of the Standard Model, but also for hopefully new discoveries. This is an incredibly powerful machine, so we would expect there are theories that explain for us, postulated theories that explain what happens beyond the Standard Model at energies even higher, which can be reached now by this new machine, and they will continue to do that. They're not yet at their full energy, so we can expect, hopefully, lots of new discoveries from CERN.
Yes, I mean, it's basically one of the landmarks of physics, and it's definitely of our time to have found this. I mean, people have been searching for this it was predicted nearly 50 years ago, and they've been building this accelerator from its inception maybe about 20 years ago to search for this particle. So this basically is one of the days we've been waiting for a long time, and certainly ever since I started studying physics, and this has really been what we've been waiting for. And basically now we're looking for clues from what we've just discovered on where to go next, and hopefully we can measure or make more measurements of this boson and find out more about it and where we should go from here in terms of fundamental physics, and discovering basically the next steps of our understanding.
1% everywhere except in the transition region between the
Okay, well, my name is Niamh Shaw, and I'm one half of a unit that created That's About the Size of It, which is a show all about CERN and the search for the Higgs particle and the implications on Joe Public, people like me, and what it means. So that's why I'm here. So we have created a show where we've, I went over to CERN and I met loads of particle physicists, and I found out about the basic science behind it, which I present in the show. And of course, up until today, nobody could say whether they found the Higgs boson or not. So that's why we were here, to try and see, do we need to rewrite the whole show or not? And that's basically it.
They have stopped short of calling it a discovery. They've called it an observation of a new particle that behaves like Higgs boson.
Yeah.
They're being ridiculously cautious. They're getting there. All it takes now is more data to come through to definitively say this is the Higgs boson. What does that mean for us as people? What does it today tell us about who we are and what we are?
Who we are and what we are. So you're made of atoms, do you? Yeah,
I do now.
Yeah. Okay. Well, we're all made up of atoms, and in school we would have learned that those atoms are made up of protons, neutrons, and electrons. Remember, you had the nucleus and everything. So once they started smashing atoms with stronger and stronger machines like the particle accelerator, they found that they're even made up of even smaller things like quarks and leptons and bosons. And over the last 50 years, they've been accumulating a lot of information, and theoretical physicists came up with this Standard Model, which basically summarises all of these subatomic particles that explains who we are and where we've come from. And for that model to be valid, all of those subatomic particles have to be found. Well, they had, except finding this Higgs boson. So they have been observing, making lots and lots of experiments for the last 3 years in CERN with the Large Hadron Collider to find this Higgs boson, and they've come very, very close today to discovering that. They knew it was going to peak in a certain range, and they're after finding a peak in that range. It is pretty likely that is the Higgs boson, but they won't know for 40 years for sure whether it's true or not.
40 more years?
Yeah, 40 more years. They know it's a boson, but it could be a whole new boson, so now they have to rule out all the other possibilities of what it's not for them to prove what it is.
We saw on the footage there from CERN this morning, there was hundreds of people in the lecture theatre, and just like here at the Science Gallery, all staring at the screen,
yes,
watching all the graphs. There was one gentleman in particular who had tears falling down his face, and that was Peter Higgs himself.
Yeah.
This is the start of, I suppose, his whole reason for who he has been, what he's been spending his entire life dedicating it to.
Yeah.
This is named after him. This is a huge momentous moment in science today.
Yeah, it is for him particularly. I mean, he was right to shed a tear. I mean, well, for the last 50 years, it's not just him. You can imagine the amount of people, everybody that's been involved, the teams that have been analysing that data, staying up 24 hours, everybody analysed the data all over the world. It's a huge achievement. It's a worldwide achievement. So, yeah, it's a big, big, big day. Big day.
Big day, but a fairly long road still ahead. I bet 40 more years.
40 more years, but isn't that the crack? I think most people I was at Cheltenham at the Science Festival, and John Ellis, one of the physicists who works at CERN, was saying in a way they kind of don't want to just yes, it's the Higgs, because then it means that their search ends. They're always wanting to look for more answers and more questions to those answers. So it's the beginning of the next chapter for them to verify conclusively the existence of the Higgs, yay or nay.
We were discussing this morning, what would happen if they announced the discovery of a particle, and some of us were actually comparing it to the moon landing of our time, really. It's an absolutely incredible discovery, and it has renewed interest in particle physics, which is the best thing that it could possibly do. For a while, I think some of us in the particle physics community were getting a little nervous, but now that we've seen this, I think this will renew interest and help us move on to further things. So, incredibly exciting.
We should state it. We have a discovery. We have observed a new particle consistent with a Higgs boson. Huh. Which one? That remains open. It's a historic milestone today, but we are only at the beginning. Now a lot of work is ahead of us. It is a milestone. I think we can all be proud, all be happy, but it's at the beginning. And I think also it has global implications for the future, and it comes at the right time, and I think we can be very, very optimistic. Thank you.